So I talked about the assignment operator a little bit earlier, but basically the assignment operator is a single equal sign. And what the assignment operator does is it allows you to change the value of a variable. Variables' values change. How do you change the value of a variable? You use assignment operators. First, you declare the variable as an integer. So you say width is going to be an integer, and we're going to set its initial value to 10. So over in memory, there's a mailbox. It has an address of width. Goes to that address and puts the number 10 in there. Here later on in our code, we assign a new value to the variable width. So now 20 gets stored in width, and now that mailbox in memory has an address of width. You open up that mailbox, you take out the 10, and you put in a 20. So a common mistake with beginning programmers is failing to initialize your variable. It says, it is an error to use a variable that has never had a value assigned to it. So here we have this variable, it's an integer, it's called height, and then we try to use height to initialize another variable, and again it's never been assigned a value. The mailbox is empty, so you get an error in that case. There's a little bit of disagreement here, and I'd like to do this experiment. Not sure if why don't we try that now? I'd like to get an answer to this question. Okay, so I'm going to open up NetBeans. And what I'm trying to figure out is it a compile time error or a runtime error when we try to use a variable that hasn't been initialized. So let's just put that in our code. Int height. When you're reading the book, it's a good idea to have your compiler open. Try some of these things. You can read about all you want, but unless you do them, you're not going to internalize them and understand them. Okay, so here's my integer height, and I'm going to set it equal to height. So the compiler is complaining here. Variable height might not have been initialized. I wonder if that's a warning or an actual error. Let's try compiling. Yeah. So the compiler says this is called a compile time error. You can't do this because of this problem. It won't let you use a variable that's uninitialized. So this doesn't make a lot of sense. It also warns you that, hey, you made this variable, but you didn't use it for anything in this method. Same thing with width. You created these variables, but you're not using them, so why are they there? So it is trying to help you. These are warnings. This one's an error. You see the red squiggly lines, kind of like misspelling something. To the compiler, this doesn't make a lot of sense, so it doesn't even let you do it. Okay, so just in graphics form, here's you have height. It doesn't have a value yet. Mailbox is empty. Now this is okay. If you actually set the variable height to a number, so we stuff the value 30 into the mailbox. Now when we need to assign that value to width, we take the value of height and we assign it as the value of width. So we take our 30, make a copy of it, and put it into the width mailbox. So now both width and height have the number 30 in it. So again, we made the syntax card assignment. Again, we take the thing on the right and assign it to the thing on the left. So now width has a value of 30. It's really a lot different than in math class. You say width equals 30. In algebra, you're doing your stuff and you're trying to define what width's value is. So you do all these contortions in your code to figure out the value of width. You could think of it as a value of x. 3x plus 5 equals 9. Find the value of x. You see that all the time. So you do all this math, and finally you get x on one side and a value on the other, and you say x equals 5. Well, x equals 5 at the end is just stating that x is equal to 5, but it's not doing anything. If I say x equals 30, in programming land, that means something completely different. You're not stating that x equals 30. What you're saying is take the value of 30 and set it as the value for x. It's very active. It goes from right to left, It's a command to the computer to do something, actually go and do something. So it's not passive, it's active. Okay? It's an instruction to the computer that says, this number 30 has to be stored in this variable over on the left side. So don't see that and think math class. That's not right. It's something else. It's more active. It's not passive. It does something. It doesn't state something like you would see in math class. It actually changes something. Now you can have the variable name appear on both sides of the equation. So you take the current width, add 10 to it, and then once you have that, overwrite the value for width and stuff that value in the mailbox. So here we have width equals 30. We can say, okay, width is right here is equal to 30, so we're going to add 10 to that, and then we're going to assign that 40 back right inside width. And you see this all the time. Now if you would see this in math class, width equals width plus 10. What's the value of width here? Is that valid in algebra? Width equals width plus 10. So what's the value of width? If this was algebra, this would be impossible, right? How can something be a number and also be the number plus 10? Doesn't make any sense algebraically. So we're taking the thing on the right, doing the equation here, and setting on the left. So you'd never see this in math class, but you see it all the time in programming land. Okay, so we saw that in the previous slide where we take width, add 10 to it, store it back into itself. So the right-hand side and left-hand side. Right-hand side is stored as the value for the thing on the left-hand side. Step by step, what does this mean? Add 10 to width, and then store that value in the variable width. So it overwrites whatever's there. First part, you get the 30, you add 10 to it, you get 40. Now you take the 40, you calculate it, and put it back into width. Here's an expression, 12 equals 12. Is that true or false? Does 12 equal 12? Well, in math class, if you were in algebra, you would say, yeah, pretty much. 12 equals 12. 13 equals 13. Doesn't sound very useful, does it? But this isn't math class. This is programming in Java. So we take the number on the right and we store it to the variable on the left. The problem is the thing on the left is not a variable. It's a literal number, or a number literal. And you can't store anything into a number literal. So even though this would be valid in math class, it's completely invalid when you're programming in Java. No, the left-hand side of the equal operator must be a variable. So how do you change the value of a greeting variable to hello Nina instead of hello world? Well, you could reset the string like this. Notice it said to change the value, so greeting must have a value already, and I think we know it's hello world. How do we get it to switch to something else? We say greeting equals, and now replace hello world with this new string. Note we didn't say this because that defines a new variable called greeting, and if you already have it, this will blow up. It says greeting already exists, you've already declared it. I don't need its data type again. I already know what it is, the compiler says. So this is how you change it, assuming that greeting already exists. And it must, because you're changing it. So we're going to stop there for today. You know, there's a lot to throw at you in one day. But again, it kind of goes over. I didn't really like the previous slide, so I wanted to go through this again just to make sure everybody understood identifiers, values, variables, and assignment operators. Our next chore is to take a look at classes and objects. This gets even more abstract. So for some people, including myself, it took me a long time to kind of figure this out. I've gone down this path so I can help you along your way, because I had to do the same thing about 16 years ago. My problem was I'd learned how to program, got a degree in computer science from a prestigious university, and then about 5 years into my career, they say, you know, everything you learned about programming, you're going to have to throw away and start over and do it a different way. And the different way was object-oriented programming. I was more a procedural or functional programmer, and the whole industry changed. It was a complete paradigm shift to a new way of programming. Only about half the programmers were able to make that program or that paradigm change. So we lost about half of them, and the rest of us had to learn it on the fly as we're trying to write code. What is this object-oriented programming? I don't even know what that is. People talk about how wonderful it is, but I don't get it. And the only way you can learn about that is by doing it. And so that first couple of years as I was learning it was very painful. Read a lot of books. If you're thinking about a software engineering career, you have to read constantly to stay up with the current trends. I always found that abstraction made it more complicated to understand. But later on in my career I realized, no, abstraction makes it easier to solve problems. But you can't come to that realization unless you've tried it yourself. Okay? So we start our discussion into object-oriented programming next time. All right, thanks.